Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you few very interesting fields of TCP segment header. Like first, I'll explain you how we have PSH flag, push flag that you can observe it is available over here, PSH bit. Then I'll explain you how we have urgent flag and urgent pointer. You can observe here, we have URG bit and urgent pointer over here. That I'll explain you by practical examples. Then I'll explain you how we have RST flag, reset flag, and at last I'll explain you how many usages are there with options field. So you can observe here we have RST bit, right, and options field over here, right. So each and every case study that I'm going to explain you by practical examples. So let us try to understand first how we have PSH flag. See, PSH that is having size of 1 bit, it is referred as push flag. So here you need to understand how we use push flag. See, here before we transmit data in between sender and receiver, there are 3 stages which is happening in TCP. First is connection establishment, second is data transfer, and third is connection termination. So when we have connection establishment, at that time, sender and receiver both have agreed upon maximum segment size. Before transmission, sender and receiver both have agreed upon maximum segment size. So you need to understand first what is maximum segment size. See, here sender and receiver both are forwarding frames over here, right? So frames are getting formed by data link layer. Here data link layer that is generating frames over here, right. Here network layer that generates packets over here, and transport layer that generates segments over here, right. So here in connection establishment, maximum segment size MSS that is getting defined in connection establishment. So sender and receiver both have agreed upon MSS. So maximum size of segment usually that is been given to network layer, and network layer will form packets, and those packets will be given to data link layer, it will form frames. So usually what happens is transport layer will be giving maximum segment size of segments to network layer. That is the usual case. But in real-time applications, you cannot wait for maximum segment size. You see, usually what we do, we fill complete segment and then we give it to network layer. Network layer will form that into packets, and then data link layer that will form it into frames, and then we transmit that on channel, right. That is what the case which is happening over here. That is the normal case. But in real-time application, you cannot wait for complete segment. You cannot wait for complete segment. Like for example, when you write something by text in WhatsApp and when you press send, at that time text data size is very small. So in real time application, if text data size is very small and if you wait for this complete segment to be filled, then your application will not be real time. So in real time application, whatever small data that we have, that we need to push in next layer. Even though size of data that is small, as our application is real-time application, by push bit we can forward this segment to next layer, that is network layer, and in receiver this transport layer will forward that to application, right. The reason is, see, push bit that is working at transport layer. So transport layer will push segment to network layer, and at receiver transport layer will push data to application layer, right. So here in real time application, as a PSH bit, if it is equals to 1, then we will be pushing data without maximum segment size, right. We will be pushing data without maximum segment size, and that we do it in real time applications like video chat, audio chat, text chat. At sender, we push data to network layer over here, and at receiver we push data to application layer over here, right? So I think now you are having fair enough idea like how push flag that is getting utilized, that we use it in real-time application, where we send data without maximum segment size, means size of segment will be lower than maximum segment size. Here we are dealing with to have transmission with real-time application, right? Now next is urgent flag and urgent pointer. You see urgent flag, URG flag that is available here, and urgent pointer that is available here. Remember this urgent pointer that is of no use as if URG bit is 0. So urgent pointer that is useful only if URG bit that is equals to 1. So obviously URG is what? Urgent. So as if you want to forward data urgently, then you will be making this bit is equals to 1, and when you make this bit is equals to 1, then which data is urgent, that we define by urgent pointer. Let me explain you how do we do that. You see, urgent flag and urgent pointer are used to send data urgently. Here data forwarding may be out of order. Remember, usually we forward data in order, in sequence. But when you have urgent data, at that time you will not follow sequence, you may go out of order, and that we do it by having urgent flag and urgent pointer, right? So here when you have urgent data, at that time those data may be out of order. Remember this. See, with the use of urgent flag and urgent pointer, we can set highest priority of data transfer. Urgent means highest priority of data transfer, right? Here there are few basic things that you need to understand. See, when you send the data on computer network, at the time that routing will happen as per frames. That routing of data that will happen as per frames, and those data is getting routed via routers. Like for example, as if I want to communicate to Google, then in between me and Google there will be probably more than 10 routers, right? So routing will happen via routers. You should know router, this router is layer 3 device. You see here in TCP IP we are having 5 layers. Router is layer 3 device. Router is layer 3 device. So router can understand up to network layer only. You see layer number 1 that is physical layer, second is data link layer, third is network layer. So router can understand up to network layer only. Router cannot see what is happening at transport layer. Remember this. So how this router will get to know this data is urgent? The reason is, see, urgent flag and urgent pointer that we define it in transport layer in TCP, that is layer number 4. But router is working at network layer. So how do we get to know like router is having idea about this data is urgent? That is possible at network layer with the use of type of service field. In IPv4 I have explained you type of service, right? So type of service can define priority. So as if type of service is equals to 7, you can say highest priority can be given to data transfer. So practically what happens is, you see, this transport layer will give segments to network layer. Network layer will form packets. So here there can be IPv4 or IPv6. In IPv4 we have type of service. So as if network layer observes this urgent bit is equals to 1, then what it does is it will make type of service field in IPv4 is equals to 7. And by making type of service is equals to 7, it gives highest priority to given frame, right? So here you will be observing router even can understand, okay, this data belongs to highest priority. So things are happening at transport layer but executed by network layer, right? Now you need to understand how urgent flag and urgent pointer that is working. So if I take one practical example, you see, if sequence number is 200. So if sequence number inside TCP header, if it is 200, then what it indicates? It indicates first byte of TCP data. It indicates what? First byte of TCP data. Now you see urgent bit that is equals to 1 here and urgent pointer that is equals to 50. So what it means? From sequence number 200, 50 bytes. So here, from here to here, we are having data. Those are urgent data. Those are urgent data. And you see the last data over here, that will be 200 plus urgent pointer. Last data of urgent pointer. Last data of urgent data. That is this sequence number 200 plus 50. So that will be 250. That will be 250. Right. So you see from 200 to 250 data will be urgent data. So if you calculate the total size of urgent data, then that will be 200 that we need to count, and from 201 to 250 in total you will be having 51 byte, right? So I have seen sometimes this question comes in competitive examination, like they are saying urgent pointer set to 1, urgent flag set to 1, and urgent pointer that is equals to 100. So how much size of data is urgent data over here? So you should know, if urgent pointer is 100, then urgent data size that will be 101. The reason is first sequence number plus urgent pointer, up to that last data will be there. So in total urgent data will be from sequence number to last, it means it will be 200 to 250, means it will be 51 byte. See, 201 to 250 that will be 50. From 200 to 250 it will be 51. Remember this. So here size of urgent data that will be 51 byte, right? So here see this urgent data may be out of order. Remember this. Now next flag, that is RST flag. If you observe here in TCP segment header, RST flag that is available over here. Now what is the use of RST flag? See, RST flag that is used to close the connection due to unexpected issues in computer network. There is always possibility that there can be unexpected issues in computer network. Like here we are having sender and receiver. Both are communicating with each other. But due to some reason, let us assume this receiver is getting rebooted over here. So what will happen? Once this receiver is getting rebooted, this receiver will not be having any idea about previous connection over here. And as there was no idea with receiver with previous connection, receiver will say to sender by RST bit is equals to 1 that we need to reboot this connection. Means from start we need to initiate. Like in TCP, what we do? At start we do connection establishment. Because of reboot at receiver, now receiver is saying, okay, again we need to do connection establishment. Then we can have TCP data transfer, and at last again there can be connection termination. But because of some unexpected issue, now receiver, see, sender is having idea like what was previous connection, but receiver is not having idea. Why? The reason is receiver was rebooted. So receiver will give RST bit is equals to 1 to sender. It says we should be having further connection establishment, then only we can have communication. Let me tell you second scenario. Like you see here, sender and receiver both are communicating with each other. Sender window size that is of 2000 byte. And let us assume sequence number 2002 3999, that is how sequence is available with this receiver window. But what if this sender is sending sequence number which is 5000? Now when this receiver is receiving this sequence number here, at that time it is observing like it is not possible to store this over here. And as receiver knows, this cannot be stored over here. Why? The reason is here we can have 2002 3999 only. You cannot receive any sequence number which is out of this. So here at that time receiver will give frame to sender by saying RST bit is equals to 1, that we need to have reboot of connection. So we need to reset the connection. Means again we need to have connection establishment. The reason is there is something wrong, right? Now there are a few interesting things that I'm going to explain you regarding options. Almost all the case studies that we have already studied in my last few videos. You see, first one is, as if wraparound time is less than lifetime, then option field is used to increase the size of sequence number by adding extra bits as timestamp. I have told you by sequence number how much size of data that is possible. Sequence number size is of 32 bits. So here we have 4 GB of data, right? But if bandwidth of computer network is large, then it is always possible there is lifetime that will be more than wraparound time. And as if lifetime is more than wraparound time, then there can be issue. And to resolve those issues, what we can do is we can increase size. How? By increasing bits. So by increasing bits using option field, we can increase bits over here. See, with 32 bits, we can have 4 GB. If I additionally add 8 bits, then 32 plus 8, it will make it to 40 bits. Now with the use of 40 bits, we can have 1 terabyte. Now for 1 terabyte, obviously wraparound time that will be higher. So we need to increase wraparound time, and it should be more than lifetime always. Then only proper data communication will happen. So to make sure wraparound time should be higher than lifetime, timestamp will be used in options field, right? And this option field says what? It says now sequence number is not only of 32 bits, it will be greater than that, right? See, this is what the basic case that we have already seen. Second scenario could be regarding maximum segment size. We have seen in connection establishment, right? In connection establishment, I have told you, see, in option field, we will be communicating regarding maximum segment size. You see, I have explained that. In connection establishment, you see, in connection establishment, first H1 will be saying H2 regarding maximum segment size. Then H2 will be saying H1 regarding maximum segment size. Once both knows what are the maximum segment size that is possible at H1 and H2, they will be agreed upon minimum of these two. So this maximum segment size communication that happens inside option field, right, during connection establishment. And third case study that is there regarding padding bits. See, we need to provide padding bits by 0. Why? The reason is here, see, TCP header length that is always super multiple of 4. Here you see how TCP segment header is there. See, TCP segment header that is having mandatory field that is having size of 20 bytes. You see, this is mandatory field, right, up to urgent pointer. We are having mandatory field that is having size of 20 bytes. Now option field that depends on what is the use. Like it is not fixed. Option field may be having 1 byte, it may be having 2 byte, it may be having 3 byte, right? And here by data offset, we define what is the size of header. Now what if size of header including option is not super multiple of 4? In that case, we need to add padding bits, and those padding bits should be 0. So by adding padding bits, we will be making option field even, which is there in terms of super multiple of 4. The reason is, see, 20 bytes are mandatory. So here in options, either you can have 4 bytes, or you can have 8 bytes, or you can have 12 bytes. Option field data that is varying from 0 to 40, right? See, TCP segment header that is ranging from 20 bytes to 60 bytes, and that variation belongs to options, right? So here, see, super multiple of 4 that should be there with options even. So here, if you have 1 byte, then another 3 bytes that will be padded by zeros, right? So that is how options are there as per padding bits. And third one is very essential. Window size determination, that we do it in connection establishment. I have explained that even. You see, in connection establishment, I have explained first H1 will be sending data to H2. That is a request in which it will be saying window size of H1. Then H2 will be replying back to H1 in which it will be saying what will be window size of H2. So this window size communication that happens by this 16 bits. That window size communication that happens by this 16 bits. But nowadays, if you observe recent computers, like I am having my computer which is having RAM of 32 GB. 32 GB RAM that is there with me. And obviously, my connection speed that is even way high. Right. So if your window size by this 16 bits, if you count that, then that could go up to what value? It could go up to 64 KB only. What if you wanted to have window size which should be greater than 64 KB? See, by 16 bits at max, how much window size is possible? 64 KB. So 64 KB that we can define by this 16 bits. But what if you need to have window size which is greater than 64 KB? In that case, we need to use option field. Right. So here what we do is, here for window size determination, if your window size is greater than 64 KB, then we will be using option field. For example, if you wanted to have 1 GB window size, 1 GB window size, then how it will be possible? 1 GB means how many bits? 30 bits. 1 GB means you need to have 30 bits. Now you see this 30 bits that we are bisecting into 14 bits and 16 bits, right? So this 16 bits that we will be having in window option field, right? Window option field. And this 14 bits that we will be having in option field, right? In option field. So see, if you have only 16 bits, then you can define up to 64 KB of window size. But if you want to have more than that, let us say 1 GB, then see, for 1 GB you need to have 30 bits. So 16 bits that we will be using it from window option field. You see, that is available here, right? 16 bits. But another 14 bits that we will be utilizing from options field. So that is how this option field that we use it in TCP segment header. I think now you are having fair enough idea about all those fields. Still, if anything that you would like to explain, or if you are having any query, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.